Hello, my name is Chamanara from University of Leibniz, Hannover in Germany. In this video, I would like to give a brief introduction to the work placement algorithms and approaches that we are going to use in the BRAINE's microdata center. In a traditional cloud computing architecture, there are two layers. On top, there is a cloud layer that is providing services like centralized services to the clients, and from the other side, the second layer are different heterogeneous and usually distributed clients that get connected to the cloud. They register different means of registration and then start using the cloud services or interacting with the cloud services and applications there. This is a very successful and valid architecture in many scenarios, especially in businesses. However, in some cases, we need some sort of like a middle layer that is doing something special. This middle layer is usually when we need like SLAs, for example, a deterministic response time for our requests at the client side, or there are some privacy issues that should be considered. Like, for example, patient information cannot be propagated to the central services or out-of-control services. So in these cases, we will have this middle layer called edge. And why we are calling this edge layer? Because from one side is basically installed at the edge of the network of the service provider. So if you think of like clusters or data centers geographically distributed and so on, or you're looking at the manufacturing assembly line and so on, these edge computers are basically installed at the edge. This means that they will be very close to the data consumption, data generation, and service interaction points. Let's say, for example, if there is a patient information system, this will be very close to those microscopes, X-rays, MRI devices, so that the data gets a shorter path to be transferred in terms of network traffic. And also, because the edge resources are dedicated to a smaller group of clients, they will get a more predictable SLA parameters like response time, delays, and latencies, and so on. And also, data is not propagated to upper layers in terms of privacy and security issues. One important point here to consider is that when we introduce the edge computers, because they are usually powerful computers, it means that we can also run applications on the edge devices, which means that those edge devices are actually enjoying a degree of autonomy. So this kind of autonomy in edge architecture should be preserved or even should be encouraged, because most of the edge computing architectures or deployments will actually rely on this degree of autonomy, or even in some cases independence, so that the decision can be made locally and also enforced locally, possibly with some degree of orchestration with upper layer cloud or enterprise services. So IBM has introduced a 4-layer edge computing architecture that I'm briefly explaining right now here. At this layer is the device layer. So here are the devices like mobile devices, stationary devices, sensors, actuators, robots, smart cars, whatever that is actually going to be part of the network will be modeled here. They will interact with the device layer to be registered, to be cataloged, and to be able to communicate with. And then based on this, because these devices will be using different technologies, different protocols, and so on, we will have a gateway layer. This gateway layer is actually enabling the communication between the upper layers like edge and cloud layers to the device layers, so that they are, let's say, protocol converters, adapters of semantic information between these two layers, translation of commands that are coming either from the micro edge data center, edge micro data centers, and so on. And then on top of this gateway, there would be the edge network or micro data centers that we are interested in. They will do the local data analysis, AI-powered algorithms, and whatever that is needed to locally interact and manage the devices. And then they also, from the other side, rely on the services provided by enterprise-level clouds for, let's say, large-scale global AI data analysis, or enterprise-level policy enforcement, and so on. So in the BRAINE project and in this work package for work placement, we are interested in the micro data center layer and the services that are going to be offered by this layer. So in general, micro data center provides AI-based services, local analytics, and also the specific applications for responding to the devices around that micro data center. So now let's take a look at inside edge micro data center, or EMDC. Inside an EMDC, from a software perspective, we have multiple layers. At the bottom, you see that we have the resources that are a heterogeneous combination of CPUs, GPUs, FPGAs, different storage mechanisms, and also networking. So on top of that, we have a resource manager, and this resource manager, in a very nutshell, is a place that keeps track of the usage, the history, and the availability of the resources, plus the information about those resources that we call it resource profile. So resource profile is that, for example, how powerful is this CPU, what it can be doing, what can be done on this GPU, and so on and so on. So on top of this resource manager, we have the work placement controller. This is where actually we want to be able to intelligently and also autonomously distribute the workload that is submitted to this EMDC. So in each EMDC, we have an operating system that accepts the submitted jobs from the upper layer, like from the cloud or from the devices and so on. Those jobs are coming to the work placement controller. Work placement controller has a machine learning or deep learning. We have actually a lot of discussion around this to schedule those workloads. So for scheduling, the algorithm takes looks at the resource profiles coming from the resource manager, and also taking a look at the workload profiles. Let's say, for example, if the workloads come with a profile that demands for a specific SLA term, this should be considered at the term of at the ML-based optimization and scheduling time. So this ML-based will have a large parameter space to decide and also to learn from the history that how to distribute a specific workload, like an application, like data gathering, like responding to an event in environments, and so on. And then when it's scheduled, the work placement plus the scheduling information will be pushed to the dispatcher, and dispatcher will talk to the resource manager to actually assign and allocate the resources and run the application on that selected resources. So parameter controller collector here is taking information from the resource manager on the current status and historical status, and also has a strong relationship and communication with the telemetry system that is not in this video. We will be discussing that in another video. to collect proper information, aggregate them or decompose them, and make them compatible to the parameters that are used by the optimizer. So this optimizer will be relying on the parameter collector for training and for continuous training, like it's an iterative process that will be retrained when the new parameters are coming in. And then we have the federation gateway. This federation gateway is basically when the EMDC is not working alone, but is working in like a federation, in a group of EMDCs that are working together to achieve higher goal. In that case, this federation gateway will be enabled to take membership on that federation group and then to get some information from the federation. I will talk about that in the next slide. So when we have different EMDCs, each EMDC inside has its local scheduler, optimizer, work placement algorithms, and so on. But at the same time, it's possible for a group of the EMDCs to establish, to build a federation, and then to choose a federation coordinator, like this one in the center, this one. And then in terms of work placement, because they have their local work placements here, and those local work placements have a model, like the AI model, those models can be shared like this with the federation coordinator, and this federation coordinator can actually combine them and create an aggregated model. That aggregated model here will be pushed back to the members so that the members not only have their local model, but also they have the global model. This helps them to find out how the overall federation is working or is placing the workloads onto different resources. This is an optional and additional feature that is going to be plugged into that federation gateway, but the federation, the EMDC nodes are not obliged to actually follow up the commands that is coming from the federation. This is a policy that at the deployment time should be enforced, that whether the members must follow the models that are coming from the federation coordinator, or they are allowed to actually to use it as their local policies are determining. So this is the general workflow of the work placement algorithm inside EMDCs and also in the federation a federation of EMDCs that is working, let's say, for example, in a hospital, or they are controlling a highway, like 100 kilometers of a highway is managed by 20, 30, or 10 of these members, and they are coordinating their work with single highway coordinator. Or let's say in a more realistic way, it would be a federation server or federation coordinator in a manufacturing line, that each device or each device in the manufacturing line is controlled by one of these EMDCs or by a partial of one EMDC, and then all these EMDCs are working together, talking to the coordinator to get like a higher level policies and higher level global ML models to actually do the optimization for the assembly line, not only for the devices that they are connected to. So this is just a brief description of the work placement in BRAINE. In the next videos later, we will go into more details of how we are going to develop this, which kind of technologies we are using, and hopefully in the near future, we will also report on the outcomes of our selection and implementation. Thank you very much. Bye-bye.